All right, in this lesson, we're going to continue on with solving the radical equations. So for the first part, when we're dealing with a more complex equation, it says Billy was given the radical equation, the square root of 3a plus 4 minus the square root of a plus 1 is equal to 3. Billy solved the equation incorrectly and he showed his work right over here. What was the error that Billy made? Well, Billy made the most common error that exists when solving these types of problems. He isolated one of the radicals, which makes sense. He said that he squared both sides, which makes sense. But then suddenly, that is not what 3 plus the square root of a plus 1 is. Remember, if I'm square rooting and there's more than one term and one of them is a radical, if I'm squaring, then I should still have a radical left over. It doesn't eliminate the radical only when I either just square radical by itself or when I multiply by conjugates. Is it going to get rid of that? Just like when we were doing our process for rationalizing. So, what was the error that Billy made? Billy did not square three plus the square root of a plus 1 correctly. X plus y squared has to equal x squared plus 2xy plus y squared. All he gave us was the first one squared plus the second one squared. So let's fix it. Like we said, the first steps I did were correct. So when he started with the square root of 3a plus 4 minus the square root of a plus 1 is equal to 3, and he moved the radical over, 3a plus 4 is equal to 3 plus the square root of a plus 1. That's correct. Then you square both sides. And we're going to do this correctly. On the left side, it's going to give us 3a plus 4. And on the right side, it's going to be the first term squared, 9, plus the first term times the second term times 2, so 3 times the square root of a plus 1 times 2, or 6 root a plus 1, plus the last term squared. The square root of a plus 1 squared is just a plus 1. And now we can keep going properly. So I still have a radical left, so I'm going to have to isolate it. I'm going to move everything else to the other side of the equation. So I'm going to subtract 9, I'm going to subtract a, I'm going to subtract 1 from both sides of the equation. And when I do that, I'm going to be left with 2a minus 6 is equal to 6 and the square root of a plus 1. Now at this point, I could divide by 6, but it's not going to divide out evenly. So even though it is being multiplied, I do just have a monomial on the one side, right here, with the radical. So when I square it, it's still going to eliminate that radical. So I'm going to square it again. And when I square both sides of this, now what I get is I get 4a squared minus 24a plus 36 on the left-hand side when I do the 2a minus 6 times 2a minus 6. And on the right-hand side, 6 times 6 is 36. And then bracket, the square root of a plus 1 times itself is just a plus 1. Which means I have 4a squared minus 24a plus 36 is equal to 36a plus 36. When I move everything to the left-hand side, I'm going to subtract 36a from both sides. I'm going to subtract 36 from both sides, and lo and behold, the 36's cancel out. They're gone. So what am I left with? 4a squared minus 60a is equal to 0. Well, I can factor this by just common factor. It's divisible by 4a, and I'm left with a minus 15 is equal to 0. Now, like with quadratics, the 4 on the outside, that's not going to change my answer at all. The a outside the brackets means that a would equal 0. And the a minus 15 means that a could also equal 15. Now, we're not done. We still need to check and see if our answers work. So, first I'm going to verify for a is equal to 0. And what I'm going to say is I'm going to have the square root of 3 times 0 plus 4 minus the square root of 0 plus 1 is equal to 3. That's going to leave me with the square root of 4 minus the square root of 1 is equal to 3. Or 2 minus 1 is equal to 3. But 1 does not equal 3, which means that we have to reject that answer. It's an extraneous root. Well, let's double check and see if 15 works. If I take the square root of 3 times 15 plus 4 minus the square root of 15 plus 1, does that equal 3? 3 times 15 is 45 plus 4 is going to be 49. And 15 plus 1 is going to be 16. Square root of 49 is 7. Square root of 16 is 4. And 7 minus 4 does, in fact, equal 3. And the left side is equal to the right side, which means that is our correct answer. For example 2, it says when the square root of 2 less than a number is subtracted from the square root of 5 more than twice the number, the result is 3. Well, first we need to decipher this. When the square root of 2 less than a number is subtracted from, that means that I'm taking that away from something else. 2 less than a number is whatever that number is minus 2. It's subtracted from the square root of 5 more than twice the number. So square root of 5 more than twice the number. And then the answer I'm left with is 3. Now we have our radical equation we're trying to solve. So we're going to say that if the square root of 2x plus 5 minus the square root of x minus 2 is equal to 3, I'm going to isolate one of the radicals. 2x plus 5 is equal to 3 plus the square root of x minus 2. And then I'm going to square both sides. Now I got to make sure I square this properly. So I'm going to say that 2x plus 5 is equal to 9 plus 6 root x minus 2's plus x minus 2. I still have a radical left here. So I'm going to move everything else to the other side. I'm going to take away an x from both sides. I'm going to take away 9 from both sides. And I'm going to add 2 to both sides. So that should leave me with negative 2. And 6 x minus 2's. Now, I'm going to square both sides again, because I can't evenly divide by 6. Make sure that I do this properly again. So on the left side, x minus 2 times x minus 2 should give me x squared minus 4x plus 4. And on the right side, I square the 6 to get 36, and I square the square root of x minus 2 to get x minus 2. Or x squared minus 4x plus 4 is equal to 36x minus 72. Got to move everything all over to the one side, so I'm going to get x squared minus 40x plus 76 is equal to 0. And now I need two factors of 76 that add up to negative 40. So negative 2 and negative 38. Based on the first factor, x is equal to 2, or based on the second factor, x is equal to 38. Now, just like usual, we need to verify. So let's verify the 2 first. And I'm going to get the square root of 2 times 2 plus 5 minus the square root of 2 minus 2 is equal to 3. Or 2 times 2 plus 5 is 9, and 2 minus 2 is 0. Square root of 9 is 3, square root of 0 is just 0, and that one works. I try the other possibility. X is equal to 38. The square root of 2 times 38 plus 5 minus the square root of 38 minus 2 is equal to 3. Well, 2 times 38 is going to be 76 plus 5 is going to give me 81. And 38 minus 2 is going to give me 36. Square root of 81 is 9. Square root of 36 is 6. And the answer works. So, what number is it? Well, we had two possible answers that work perfectly fine. So we can say the number is 2 or 38. Both answers work. All right, go ahead and get some practice.